Okay, Lamai, I'm starting the class. Now, the last session, we completed the MCQ up to the 30th question. Now, these are the MCQs that you have to continue. 33rd one and the 35th one. Then, in the next page, 38th, 39th, 40th, 41st, 42nd, 43rd, 44th one. Okay, let's continue. I'll add more questions. Let's start. Okay. In the 33rd question, a stone is dropped from a height. H. Simultaneously, another stone is thrown up from ground, which reaches a height 4h. The two stones cross each other after a time. Okay, I'll use two colors. One is dropped from a certain height. A stone is dropped from a height h. 33rd question. There's a stone. It is dropped. Drop means initial velocity is 0. It's dropped from a height h. This stone is dropped from a height h here with a 0 initial velocity value. It is dropped from a height h. This height is h. And again, there's another stone. Another stone is thrown up from the ground, which reaches a height 4h. Another stone is thrown up from the ground. Another stone is thrown up. Let's say the velocity is u dash. It has an initial velocity. That velocity will take it for a maximum height of 4h. Okay, before turning back, this initial velocity of the stone that was thrown from the ground will take that stone to a height 4h before turning back. So these are the facts that they have given. Now what they ask: the two stones cross each other after a time. What is the time that these two stones will cross each other? I'll say this one is capital B, and the one which was dropped from a height, let's say it's capital A. What is the time that this A and B cross each other? That's what they ask. Okay, I'll go to another picture. In the second picture, I will draw the image where they are passing each other. Now, this was dropped from a height h. From that height, now it's coming. From its initial height h, it's coming. At t equals 0, it was in a height h. Now it's coming downwards. At a time t, it is in a position like this. And at that time, what happens? The capital B stone, which was projected from the ground, now it's moving upward, and it also passed the same place. Simultaneously means at the same time. When this one was dropped, simultaneously means at the same time. So when this one was dropped, this was projected. So when t equals 0 here, when this was dropped, t equals 0 here. So at t equals t, it comes to a level that I'm showing here. And from ground, b is coming upward and it will come to the same level at time t. As both of them started simultaneously. Both of them started simultaneously. So when they are crossing each other, time is spent by each stone is same. Both of them started simultaneously. So at the moment when they are crossing each other, both has spent same time in their motions. Okay. Now, there's a fact given. This capital B stone is reaching up to a level 4h before turning back. Shall I use that 4h value to take a equation which is related with the initial velocity of the stone B? Okay. For the stone B, for B, up to its max height, for B, up to its max height, I am applying V square is equal to U square plus 2As. For B, the stone which was thrown from the ground is B. It reaches a height 4h before turning back. So I'm applying V square equal to U square plus 2As for that stone. At the maximum height, it will have a 0 velocity just before turning back. Initial velocity is U dash square here, 2 minus G. H means the height, the maximum height until the velocity becomes 0. It's 4h now. In terms of h, it's 4h. So 8gh. I'm taking this to other side. 8gh is equal to root 8gh. Root 8gh is equal to its initial velocity. The stone which was thrown from the ground with the velocity u dash reaches a height 4h. I use that 4h, that fact to take a idea about its initial velocity. Now I have an equation. This initial velocity of the stone which was thrown from ground is having a value of its initial velocity, root 8gh. And the stone which was released from a higher point, it was starting from a 0 velocity. Now, for capital A means the stone which was released from a certain height. For capital A, now initially A is in height h. A is in height h. Initially, A is in height h. And it was dropped from there. And I'm saying it is coming a distance x. It's moving a distance x downwards when it crosses with the capital B stone. For A, from t equals 0 until B, for A from t equals 0 until they cross each other. Okay, for A, now it was released from a height h. When they are crossing each other, I'm saying that this A is traveling a distance x in the downward direction. So applying S equals ut plus half at square. Applying S equals ut plus half at square downward. It's coming a distance x when it crosses the B, when they are in the same level. That means when they are in the same level, capital A has reached a distance x. X is equal to, it was dropped, initial velocity is 0 plus half acceleration of gravity 10, let's say g t square. So x is equal to g over 2 t square. X is equal to g over 2 t square. For A, from t equals 0 until they cross each other, the distance it comes is equal to half gt square. Okay. Then for B, until they cross each other, I'm applying S equals ut plus half at square. For B, until they cross each other, I'm applying S equals ut plus half at square. Okay. Here, when applying S equals ut plus half at square for B until they cross each other, I'm saying capital B is moving a distance y in this upward manner. To cross with A, capital B has to move a distance y upward. Y is equal to, its initial velocity is u dash, time spent is t, plus minus g t square, So it is the equation that I am using with capital B. It was thrown with the initial velocity u dash to cross the stone which is coming from the upward direction. It has to travel a distance, a displacement y upward. That's what I'm saying. So y is equal to its initial velocity u dash. The time is spent until it crosses the other one is t plus half minus g t square. Okay. Then what is this y? Y is equal to u dash. From the fact that capital B reaches a distance 4h before turning back, we found u dash is equal to root 8gh. Root 8gh. 8gh t minus g over 2 t square. That is the distance y. Okay. Now x is equal to gt square over 2. For y, I have another equation. I know x plus y is equal to h. Why? H is released from a height h. Its capital A is released from a height h. It's coming a distance x downward. Meantime, capital B projected from ground, moving a distance y upward, and they will cross each other. So, from this diagram, it's very clear that x plus y is equal to the h value. X plus y is equal to the h value. X plus y is equal to h. So, this is the situation. And only unknown fact to come in this route was the initial velocity of capital B, but they have given an extra fact that it was moving a distance 4h before turning back. I used that to find its initial velocity. So now it's clear. I can continue the path. X, the distance that capital A is coming downward, g over 2 t square. G over 2 t square. Y, the distance that capital B will move to cross with A. Root 8gh minus gt square over 2. X is equal to gt square over 2. Y is equal to root 8gh minus gt square over 2. Complete value x plus y is equal to h. So this gt square over 2 will cancel out very easily. So root 8gh is equal to h. Okay. There's a t value here. There's a t value. Y is equal to root 8gh t minus gt square over 2. Here there's a t value, root 8gh t minus gt square over 2. That's a root ut. U dash value, the velocity root 8gh, you have to multiply it by t. So there's a t here. root 8gt, this gt square will cancel out plus and minus values. Here you have h. Root 8gh, t is h. Okay, so t is equal to h over root 8gh. Normally, the normal h means root h into root h. Normal h means root h into root h. Here you have root 8g and root h. H means root h into root h. Root 8gh means root 8g into root h. One root h will cancel out. So what is the time t? The root h is in this h is in this place and 8g is in this place. Root h over 8g. Answer is B. Answer is B. Okay, let's continue. After finishing the 44th question, th 47th, 50th, 58, 60, 61, 60, 61, 70, 76, 84, 85, 90, 103, 107. Okay. Question number 35. Question number 35. The speed time graph of a particle moving along a straight line is shown below. The distance covered by the particle in 10 seconds time. In question number 35, that's a speed time graph. It's not a velocity time graph, as they say, it's a speed time graph. It's a speed time graph. So this is the space time graph. Not space time. Space. I'm sorry, not space time. Speed time. Okay, space time is a very hard concept in relativity. In Albert Einstein's relativity, space time is a very good factor. No, this is not that. Speed time. Here, this is the speed time graph. And they ask you the distance covered by the particle. Okay, remember, in a velocity time graph, the area under the curve will give you the displacement. And in a speed time graph, area under the curve will give you the distance. In a speed time graph, area under the curve will give you the distance. So the distance is the area under the curve in a speed time graph. It's a triangle, half, the base is equal to 10 and maximum height is equal to, perpendicular height is also equal to 10. So 50 meters. Okay, it's an easier one. Answer is B. Answer is B. Okay. Then in the then I'm moving to the 38th question. දවසම වැඩ පුතේ එකෙන් මේ තමයි පටන් ගන්න වෙලාව පොඩ්ඩක් එහාට මෙහාට උනේ. ක්ලාසස් වල වැඩ රිවිෂන් එක පටන් ගන්නවානේ next week. ඊට කලින් මේ නිමාඩු කාලේ ලොකු අයලාගේ additional classes වගේක් දාලා syllabus එක ගොඩක් ඉස්සරහට ගත්තා. syllabus එක අපි කලින් ඉවර කරලා දෙනවානේ. ඉතින් ඒ වැඩේට යෙදිලා දැන් ඊට පස්සේ next week ඉඳලා revision එකනේ. මම තමයි වැඩ ටික හොඳට කරගෙන යමු. 38 1. The velocity time graph of a particle moving in a straight line is given below. The velocity time graph of a particle moving in a straight line is given below. The acceleration of the particle at t equal 9 is equal to. Okay, this is a velocity time graph. This is a velocity time graph. It's like this. In this velocity time graph, (5 meters per second, 10 meters per second, and here 15 meters per second. This is at the 4th second. This is at the 8th second. This is at the 10th second. And this is the 12th second. Okay. The velocity time graph of a particle moving in a straight line is given below. The acceleration of the particle at 9th second. Okay. So, where's the 9th second? 9th second should be somewhere here. 9th second should be somewhere here. Here, between 8 and the 9, between 8 and the 10th seconds, there lies the 9th second. Acceleration of the particle at the 9th second. in a velocity time graph, acceleration is given by the gradient. So when you add the 9th second, the graph is something like this. Okay, the gradient at the 9th second is the gradient of this total of this complete straight line. Why? This is a straight line. In a straight line, the gradient won't change. So you are asked to find the gradient at the 9th second. No matter what, between 8th and the 10th second, it's the same straight line. So you can freely find the gradient of this straight line. It will be the gradient at 9th second also. Okay, so I am going to find the gradient of this line. That's what I have to do. It is the acceleration at the 9th second also. Okay, to find the gradient, actually the gradient is the angle that the line is creating with the positive x-axis. So this is the positive x-axis. So this will be alpha and gradient will be this tan alpha value. The gradient is the angle, the tangent of the angle that the straight line is creating with the positive x-axis. So this is the alpha value, and so this is the tan alpha. I have to find this tan alpha is for this straight line. That is the straight line that the motion carries. That's the behavior that the motion has when it's in the 9th second also. So I am finding the gradient of this straight line. To that, I have drawn the positive x-axis and I have taken the relevant angle. I have to find this tan alpha. There's a method to find tan alpha here. If this is alpha, the obtuse angle will be 180 minus alpha. If this is alpha, this part will be 180 minus alpha. I can find tan 180 minus alpha from this and this. So this is the trigonometrical equation that I am going to use. Tan 180 minus alpha is equal to tan alpha. Tan 180 minus alpha is equal to minus tan alpha. I'm sorry. Tan 180 minus alpha is equal to minus tan alpha. So in this, from this side, tan 180 minus alpha, 15 minus 5 divided by this leg, 10 minus 8. Tan 180 minus alpha. Okay, opposite leg, 15 minus 5. Adjacent leg, 10 minus 8. It's equal to minus tan alpha. 15 minus 5, it's 10. 10 minus 8 is 2. Equal to minus tan alpha. 5 is equal to minus tan alpha. Tan alpha is equal to minus 5. Tan alpha, now from this trigonometrical equation and from this technique, finally I got tan alpha. Tan alpha is the tangent of the angle that this straight line is creating with the positive x-axis. So that's the gradient. Gradient of a velocity time curve will give you the acceleration. So acceleration is equal to minus 5 meters per second. So not even in the 9th second, from 8 to 10th second, 9th second also, from 8 to 10th, whatever the situation, this is the straight line. So it represents the acceleration, it's minus 5. So the answer is minus 5. The retardation is 5 meters per second. Okay. So the answer is, now here, be careful, they have asked you the acceleration. If they ask you the retardation or the deceleration, it's 5. But they ask you the acceleration, so it's minus 5. Be aware. Now they ask you the acceleration. If the acceleration is cast, it's minus 5. So the answer is C, not the B. Okay. Now, then the 39th question. 39th question. 33rd, 35, 38. Now I'm going to the 39th one. 39th one. A bullet fired into a fixed wooden block loses half its velocity after penetrating 60 centimeters. It comes to rest after penetrating a further distance of. That's a wooden block. A bullet is fired. This is the bullet. Let's say when it hits the block, it has a velocity of v. After 0.6 meters, it has lost half of its velocity value. Now it's having a velocity of v over 2. After 0.6 meters inside to the block, it has dropped the velocity from half value, where initially the value, into a half. Okay. Now I am applying v square is equal to u square plus 2as for the first 60 centimeters. I'm applying v square is equal to u square plus 2as for the first 60 centimeters. After the first 60 centimeters, its velocity has dropped to a v over 2 value. So the finite velocity after 60 centimeters is equal to v over 2 square. Initial velocity will be v square. 2, acceleration is minus a. Now in a wooden block, when the bullet is passing a wooden block, definitely it slows down due to the frictional force from the wood. So what happens? It's a deceleration. It loses the velocity when it is penetrating through the wood. Okay, so it's a deceleration. I applied minus a. After 60 centimeters, the velocity is v over 2 square. Initial value v square minus 2a minus after 60 meters, 0.6 meters. Okay. V square over 4 is equal to v square minus 2 into 0.6, 1.2a. So 1.2a is equal to v square minus v square over 4. 1.2a is equal to v square minus v square over 4. 1.2a, v square minus v square over 4. 3 over 4 v square. 3 over 4 v square. 1.2a, 3 over 4 v square. Okay, now I have a method to continue the sum. Now I know the acceleration value in terms of initial velocity that it hit the block. Now the acceleration value is equal to 3v square over 4 into 1.2, 4.8. Now I have a answer for the a value. It's 3v square over 4.8. Now this is the value of the deceleration. This is the magnitude of the deceleration. When it passes the wooden block, it slows down. So the acceleration is a minus 1. Here I applied the minus mark for the acceleration. So from here I got the magnitude of it. I provided the minus mark at this point. So the velocity will reduce into v over 2 when the initial velocity is v after 0.6 meters. So it's a deceleration. So I provided this minus mark for the acceleration from here, from the beginning. So now what I got is the magnitude of this deceleration, 3v square over 4.8. I know it's a deceleration, velocity drops, so I gave that minus mark from here. So no need, I will not get it again from here as I have given it here. Now I got the magnitude of that deceleration. Now as this is the same wooden block, when the bullet is moving forward, the frictional force acting on the bullet at this point will be the same frictional force that acting when the bullet is penetrating more. Why? It's the same wooden block. So the frictional force acting on the bullet when it is moving forward is same everywhere. So this deceleration value is same everywhere. Now from the initial 0.6 meters, I found this deceleration value. The value I found for the deceleration, I can apply it for the further movement also. Why? It's the same movement block. The frictional force is same throughout the motion. So the deceleration that the bullet gets is the same value. So the deceleration value I found from this initial 0.6 meters, I can apply it until it stops. So what they ask, it comes to rest after penetrating a further distance of. It comes to rest means its final velocity will become 0. It comes to rest means its final velocity will become 0 after distance x, after further distance x. Now applying v square is equal to u square plus 2as from 0.6 meters until it comes to rest. Okay. Apply v square is equal to u square plus 2as. Apply v square is equal to u square plus 2as from 0.6 meters until it comes to the rest. Okay, when it comes to rest, its final velocity will be 0. At this stage, its velocity will be v over 2. From v over 2 until it comes to rest, what is the further distance that it moves under this deceleration? That's what they ask. So at rest, at the end, final velocity is 0. At this position, it's v over 2. I'll take it as the initial velocity plus 2. Deceleration is minus, deceleration is the thing that we have here. So it's a minus acceleration, 2 minus a. The further distance is x. So 2ax. 2a is equal to v square over 4. 2ax is equal to v square over 4. So what is v square? V square is equal to 4.8a. V square is equal to 4.8a over 3 is the value for v square. V square is equal to 4.8a over 3. 4.8a over 3 is the value for v square, and you have additional 4 here. A will cancel out. So what is x? 4.8. You have to take 2 to this side. 2, 3, 4. X is equal to 4.8 over 24. Okay. 0.2 meters. After the first 0.6 meters, it has dropped its velocity to a half value from the beginning, and due to this frictional force acting upon the bullet from the wood, there's a retardation throughout the motion. That retardation is constant as the frictional force is constant, as this is the same wooden block. So from this v over 2 velocity value, it will move another distance x until it comes to rest. That x value is equal to 0.2 meters. That x value is equal to 0.2 meters. That's what we got. Okay. Now move to the 40th question. Move to the 40th question. Can you remember the most important thing that I mentioned last week? From next Wednesday, you have to face the first exam. from next Wednesday, you have to come to the class and you have to start writing the papers. Before the term test, we have to write papers and get practice. So we'll start in this paper program from next Wednesday. I'll give you the time allocations. Then you can come and write the paper. And I'll mark the paper and then we'll discuss. Okay. Now the 40th question. So I ask you to start studying from the beginning until the relative motion. Relative motion is not a big lesson, so you don't need to start it that much. It will take 1 or 2 hours to finish the complete lesson as it's a small one, but up to projectile, it's very important. So start studying from the beginning up to the relative motion. That means up to projectiles. Let's say relative motion. Okay, let's start. And be prepared from next Wednesday. You can come to the institute and write the paper. Okay. Then I'll be marking the paper, giving marks. Then we have to discuss it. Okay. Meantime, on this Sunday, we have to start force and Newton laws. From this Sunday, we have to start force and Newton laws also. Okay. The displacement time graph for a particle moving in a straight line is shown below. So this is a displacement time graph, time t. Displacement is okay. This is point A. This is point A. This is point B. This is point C. This is point D. The displacement time graph for a particle moving in a straight line is shown below. The acceleration of the particle during intervals OA. O is this point, the origin. OA. These are the time periods AB, BC, CD. What will happen to the acceleration of the motion in these time periods? That's what they ask. OA, in a displacement time curve, the gradient will give you the velocity. So from O to A, gradient is positive decreasing gradient. Now you have the short note in your room. You can see that. You can check that. This is the positive decreasing gradient. So the velocity is positive, it's decreasing. When the velocity is decreased, velocity is positive means it's moving to the direction where the displacement is positive. In sign convention, you know, if the displacement is considered as a positive value to a certain direction, the velocity towards that direction is also positive. So this gradient is positive decreasing. The gradient positive means velocity positive decreasing. There, the velocity decreasing. If the velocity is decreasing, acceleration is minus. If the velocity is decreasing, acceleration is minus. Then from O to A, displacement time curve, the gradient is the velocity positive and it's decreasing, velocity decreasing, that means it's a deceleration, acceleration is minus. From A to B, object is at rest. The time passes, but the displacement does not increase, does not decrease. From A to B, the time passes, but the displacement, it does not decrease, it does not increase. So what do you mean by that? It's in a rest. So from A to B, the object is at rest. In a displacement time curve, this is not a velocity time curve. In a velocity time curve, if this straight line is there, it's a constant velocity. But this is a displacement time curve. In a displacement time curve, when the time is passing, if the displacement is not increasing or decreasing, object is at the same place. So it's at rest. So acceleration is 0. From A to B, acceleration is 0. From B to C, it's positive increasing gradient. The shape from B to C, it's positive increasing gradient. So the velocity is positive. It's in the same direction of motion and positive increasing gradient. Velocity is increasing. Velocity is increasing means acceleration is positive. From C to D, this straight line hints a constant grade, positive constant gradient. If it's a straight line, if the graph is a straight line, it's a positive, it's a constant gradient. If the graph is a straight line, it's a constant gradient. And if it is making a acute angle with the positive x, it's a positive constant gradient. Okay, so this is a positive constant gradient. The gradient hints the velocity. Velocity is constant. That means acceleration is 0. Acceleration is 0. So this is the method that the acceleration changes. So minus 0 plus 0. Minus 0 plus 0. The answer is the part is in C. Answer is in C. Okay. Then question number 41. Question number 41. The velocity time graph of a body is shown below. It indicates that, so this is the velocity time curve. The velocity time graph of a body is shown below. It indicates that at B, force is 0. At B, the velocity time curve is a minus constant gradient line. This line, it's creating a obtuse angle with the positive x-axis. If a straight line is there and when it's making obtuse angle with the positive x, it's the minus constant gradient. It's the constant gradient. The value is minus. This is straight line from here to here. It's minus constant gradient. Okay. In a velocity time curve, the gradient is the acceleration. So it's a minus constant acceleration. So when the object is, when the graph is from here, when the graph starts from here and until this place, in between, the graph indicates a minus constant gradient situation. So the object is in a minus constant acceleration. That means object is in a deceleration with a constant value. Okay. Okay. If there's a deceleration, to decelerate the object, there should be a frictional force to drop the velocity. So at B, force is 0 means it's incorrect. A is not correct. At B, the graph indicates a minus constant gradient. That means a minus constant acceleration, as this is a VT graph, minus constant acceleration. Minus acceleration means retardation. So the object slows down. To slow down an object, there should be a force in the opposite direction. So the force is 0. That's what they say in the statement A. So it's wrong. B, at B, there is a force but towards motion. It's also wrong. At B, object is in a decreasing velocity phase. Why? At B, it's a minus constant gradient graph. That means it's a minus acceleration. That means a deceleration. To decelerate the object, there should be a force in the opposite direction. So at B, force is towards motion. It's wrong. Force is opposite to the motion. C, at B there is a force which opposes the motion. C is correct. C is correct. That's what I told. D, none of the above is true. It's also wrong. C is correct. At B, velocity is decreasing. To decrease the velocity, there should be a force in the opposite direction of the motion. That's what you have to take. Statement C is correct. Okay. Then question number 42. Question number 42. The displacement time graph of a particle is shown below. It indicates that. So this is the displacement time graph. So in this displacement time graph, in this place, gradient is positive decreasing. Look at your short note in the wall in your room. This is a positive decreasing gradient. In a displacement time graph, gradient gives the velocity. So velocity is positive, it is decreasing. And from here, the graph is moving with the positive x-axis. So the angle inside is 0. This is the positive x-axis and graph is lying on the positive x-axis. So the angle in between the x-axis and the graph is 0. So tan theta is equal to 0. The gradient is equal to 0. So the velocity is 0. That means in this case, object has stopped. So initially there's a velocity. Initially, let's say I'm drawing the tangent at the beginning. I'm drawing the tangent at the beginning. So there's a good tan alpha value. That means there's a good gradient. So there's an initial velocity. After the initial velocity, now the gradient is positive and decreasing. Velocity is decreasing. Object start with the initial velocity. Velocity is decreasing, and this part represents the rest. It comes to rest. So what is the correct statement? The particle starts with a certain velocity, but the motion is retarded, and finally particle stops. Correct statement is A. It starts with a certain velocity, then acceleration gradient is positive decreasing, velocity is decreasing. To decrease the velocity, it's the retardation, and then object is at rest. No displacement increasing or decreasing, then just time passes. That means object is at rest. So statement A is correct. Statement A is correct. Okay. Then question number 43. Then question number 43. Question number 43. So this is the velocity time curve. At the 4th second, velocity will be in its highest value, 2 meters per second. And at the 6th second, velocity becomes 0 again. Then the velocity is improving in the minus side. Velocity becomes minus 2 at a time of 8 seconds. Then suddenly the velocity comes to the positive side, and from 8 seconds to 10 seconds, velocity is kept constant with the +1 value. So kind of a complex motion. Now what they ask, the velocity time graph of a body moving in a straight line is given below. The displacement of the body in 10 seconds is. Okay. in a velocity time graph, the displacement is given by the area under the curve. But there's a small thing. If the velocity is minus, that means object has turned back. It's coming back. Velocity minus means the opposite direction to the initial direction. So the minus velocities indicates the motion in the opposite direction. So I'll find the area under the curve when the velocity is positive. Let's say A1, area under the curve when the velocity is positive. Half, base is 6 and the height is 2. So 6 ms minus 1. So the area under the curve when the velocities are positive is equal to 6. Is equal to 6. That means from a certain point, object has moved for 6 meter distance. After then, what happens? The velocities become negative. Velocities will become negative when the object turns back. Okay, so now it's coming to the opposite direction. And there's a small thing you have to remember. I have taught you this. When in a velocity time curve, first you have to find the area under the minus velocity, and remember that area under the minus velocity will give you the distance which it came back. Area under the minus velocities will give you the distance which it came back. So I'm finding this area, half, base is equal to 8 minus 6, max height is equal to, value wise it's 2. The minus 2 means the opposite direction. What's the area? Half, triangle, base 8 minus 6 and the height is 2. So what will happen? Area is equal to 8 minus 6, 2 meters. So it has moved another 2 meters to the opposite direction. Then suddenly the velocity becomes positive. Then let's find the area under the curve after the 8th second. A3. It's a rectangle. 10 minus 8 multiplied by 1. What is this area? 10 minus 8 multiplied by 1. 2 meters. So again, it's under positive velocities. That means again object has changed its direction and moving back. Moving to the initial direction. Came for 2 meters to this side and moving again another 1 meter for the initial direction. So this is the motion. 6 meters to the initial direction, coming back for another 2 meters and then again change the direction and move into the initial direction for another 1 meter. Okay. So what is the displacement? Let's say we start to measure the displacement from this place. Initially, after the first positive velocities, the displacement is 6. And the negative velocity side A2 give you the distance it came back. It came for another 2 meters. Moved 6 meters, came another 2 meters to the opposite. So now the displacement is the gap between the initial and the final position. So the displacement is 4. But it does not stop here. Stop from there. Again moves another 1 meter the initial direction. So the complete displacement will be 5 meters. Moved for 6 meters. Displacement is 6. Came 2 meters to the opposite direction. So the gap with the initial place is 4. That's the displacement. Now the displacement is 4. But again turned and moved in the initial direction for another 1 meter. Now the gap between the first and the final point is 5. So the displacement is equal to 5 meters at the 10th second. At the 10th second, displacement is equal to 5 meters. 6, 4, 5. Here it's 2. Here it's 2. I'm sorry. Here it's 2. I'm sorry. It's 2 here. Moved 6. Came 2. Again moved another 2 to the initial direction. So 6, 2, 2. So the displacement is 6. Displacement is 6. Okay. 43rd one. Now I am moving to the 44th question. Now I'm moving to the 44th question. Today I'm going to finish up to the 50th question. Then from next week, I'll be continuing with the 58th one. Okay, let's continue. I'll mark the questions. 58, question number 58. Then question number 60, 61, 70, 76, 84, 85, then question number 90, 103, then 107. Okay, today I am finishing up to the 50th question. Now the 44th one. A balloon rises from a rest with a constant acceleration g over 8. Now this is not the normal balloon. Last week we solved a problem in this manner. There are some balloons which is used to carry